Welcome to MyProjectBazaar.com. Let me discuss about the process MIMO-OFDM wireless channel prediction by exploiting spatial-temporal correlation. Let me discuss about the abstract of the project. Wireless channel change due to the mobility of users, which coupled with system delays causes outdated channel state information to be used for transmitter optimization techniques such as adaptive modulation. Channel prediction allows the system to adapt modulation methods to an estimated future CSI. The primary contribution of this paper is a low complexity channel prediction method using polynomial approximation. Temporal variation and frequency selective of wireless channels constitute a major drawback to the attainment of high gains in capacity and reliability offered by multiple antennas at the transmitter and receiver of a mobile communication system. Limited feedback and adaptive transmission schemes such as adaptive modulation and coding, antenna selection, power allocation and scheduling have the potential to provide the platform of attaining the high transmission rate, capacity and QoS requirements in current and future wireless communication systems. These schemes require both the transmitter and the receiver to have accurate knowledge of channel state information. Time division duplex and systems CSI at the transmitter can be obtained using channel respiratory. Accurate knowledge of time-varying wireless channel characteristics is important for current and future wireless communication systems, where the channel power may vary by several orders of magnitude over a very short spatial distance traveled by a mobile terminal. These schemes consider the time-varying channel as the stochastic wide sense stationary. Knowledge of the temporal autocorrelation function for protection without explicitly modeling the physical scattering phenomenon causing the fading. Let me discuss about the flow diagram for our process. Initially, the OFDM system model has been designed. A MIMO-OFDM system with M transmit antenna, N receive antenna and K subcarriers. All at the transmitter, the transmitted symbol is transformed into the time domain signal. At the mth transmit antenna, ith symbol time and the kth subcarrier using IFFT. Then a cyclic prefix is inserted to avoid inter-symbol interference. At the receiver, the CP is removed from the FFT process. CP is greater than the maximum delay spread of channel. The time and frequency synchronization is perfect. The received symbol at the nth receive antenna can be represented. Impulse response of the wireless channel can be represented. At least square channel estimation at the pilot location using received symbol. Then the spatial correlation matrix has been estimated. Performance of wireless communication systems can be improved by having multiple antennas at the transmitter and receiver. The idea is that if the propagation channels between each pair of transmit and receive antennas are statistically independent and identically distributed, then multiple independent channels with identical characteristics can be created by pre-coding and be used for either transmitting multiple data streams and increasing reliability. Channels between different antennas are often correlated and therefore the potential multiple antenna gains may not always be obtainable. Next, the spatial-temporal channel prediction algorithm has been proposed. Here, forward stepwise subset predictor and a reduced complexity FSS predictor has been introduced. A reduced order AR predictor is proposed in this subsection, which aims to reduce the computational burden of the all correlation predictor. In this algorithm, the observations are not considered to be equally important for prediction. Some observations just offer little information for the AR model, particularly if a domain datum is independent with the predicted datum, and then the datum has no help for prediction. Finally, the performance has been analyzed. Here, minimum mean square error. The minimum mean square error estimator is an estimation method that minimizes the mean square error, which is a common measure of estimated quality of fitted values of a dependent variable. Next, bit error rate has been estimated. The number of bit errors in the number of received bits of a data stream over a communication channel that have been altered due to noise, interference, distortion, or bit synchronization errors. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right-click the file and run for executing this process. Here the OFDM signals are generated. Here the OFDM transmitter as well as the OFDM receiver blocks are performed. After implementing the OFDM symbol, we have to estimate the MMSC predictor. This minimum mean square error predictor here is used. This is the our enhancement method of our forward error predictor algorithm. Here this is the input data signal and displayed in the graphical representation. This is the encoded input data using conventional encoder. This is the modulated signal using QAM modulation. This is the constellation diagram for our 16 QAM modulation scheme. This is the pilot insertion. After performing modulated signal, we have to insert the pilot sequence, and this is the AWN channel, that is noise channel, and this is the removal of pilot. This is the OFDM reversal process, and this is the demodulated signal. This is the scatter plot representation of our 16-bit QAM demodulation scheme. This is the received data after performing the OFDM receiver process, and this is the BER versus SNR graph representation, and this is the BER versus SNR graph for our various modulation schemes. This is the BER performance with 16-bit QA modulation. This is the 64 QA modulation for our bit rate graph, and this is the MMSC graph by varying the SNR. Here we perform the graph on various correlation prediction schemes, and this is the MMSC graph for between various correlation prediction schemes, and this is the MMSC and SNR graph by varying the correlation prediction schemes. Finally, MIMO-OFDM schemes by varying the correlation spatial correlation matrix of our proposed system based on the MMSC has been estimated. Thank you.